Yeah.
You might have gotten away with it because it's not like you're an idea when you get slider, but you're not supposed to be able to touch it.
All right, guys. Here's the assignment from 741. We finished it up yesterday.
I gotta go up there for bigger.
Because I can run more off if we need them. Yeah, because it's the one we've been working on all week. Yeah. 2 days for sure. I can't remember if you were here Monday. I don't know why. Yeah, but I can run another copy of it. Yeah. Yeah, because we started 741 on Monday. It just took us 2 days to get through it. Yeah, and I did take longer than probably, we could have gotten it done quicker, but I wanted to make sure that y'all had a good understanding of it. 4 through 6, 8, 12 through 14, 20, 23. Now, before we get started with today's lesson, are there any questions on any of the homework assignments? Any of the homework problems that y'all want to see done at work? Real good so far. 7-1, 7-3-1, 7-3-2, 7-4-1. And we're on 7-4-2. All right, guys. Here we go. 7-4-2. Simplifying complex fractions. So we're simplifying complex fractions. There's two main ways to do these. One of them is to simplify the top and bottom, and then simplify the fraction as a whole. And another is using the least common denominator. So if we look at this first one here, we have 5 over x plus 4 over 1 over x plus 4 plus 2 over x. So we have these two fractions. I'm going to go and show you the first method. The first method is to simplify the top of the fraction and the bottom into a single fraction. So I would watch this first method here. Now the top of the fraction, 5 over x plus 4, is as simplified as it gets. There's nothing we can do to it. But the denominator, we have two separate fractions. And we're going to have to get those denominators to be the same. So we're going to look at the bottom of the fraction and see what the least common denominator is. One of them has x plus 4. The other has x. Well, incidentally, the least common denominator is just going to be x times x plus 4. Nothing in common. We need one of each. One of just the x term, one of the x plus 4. So what that means for us here is that our 2 over x is missing the x plus 4 on bottom. So we're going to have to multiply it by x plus 4 over x plus 4. Our first one, our 1 over x plus 4, its denominator is missing the x. So we got to multiply by x over x. Now the top of the fraction is not going to change. It's still going to be 5 over x plus 4. Now the denominators are going to multiply. So the one on the left here, our x over x times 1 over x plus 4. On top, our 1 times x is going to be x. On bottom, we're going to have x over x times x plus 4. Make that. Our second fraction, the denominator's going to be x times x plus 4, because again, we wanted these denominators to be the same. Now, we are going to have to combine the numerators. We're going to have to combine like terms. So we're going to have to multiply through. Our 2 times x is 2x. Our 2 times 4 is 8. Looking for yesterday's or? Yeah. 741 was yesterday. We're starting 742 today. This. Questions on this so far? Now, since the denominators are the same in the denominator of this fraction, we can add the denominator's numerators. So we're going to have x plus our 2x plus 8. Now, we can put parentheses around it, but because of the addition, signs aren't going to change. We don't necessarily need them. Yes. Now, once we simplify this, x plus 2x is going to give us 3x plus 8 over x times x plus 4. So this was the goal of the first method, is to get it so that we have one fraction on top, one fraction on bottom. Is the first main step. Now the second main step is to rewrite this fraction as the numerator, the top of it, divided by the bottom, the numerator divided by the denominator. Question? On which note sheet? Okay, so today is 742. So we have a new note sheet for today. Is that what? So 731 was last week, our multiplication division. Yes. So Monday, Tuesday, Wednesday was 1. 741. So today, you got a new note sheet for today, yes? Okay. 741 was Monday, Tuesday, Wednesday. That was one set. Yeah. Last Friday was 732. Yeah, so that was the Wednesday, Thursday before, yes. Because last week we did 741. Yeah, and I can get that for you. Yeah. And we can worry about that here in a minute. So, everybody good up to this point. Now, we can do this and rewrite it as a fraction in a fraction. The division, because a fraction is just another way to say we're dividing the top by the bottom. And since we're dividing two fractions, we can change it from division to multiplication by keeping the first one the same, switch it from division to multiplication, and flip our second term. And now we can multiply these together. On top, we'd have 5x times x plus 4 over x plus 4 times 3x plus 8. Well, we have an x plus 4 in common on top and bottom, which leaves us with 5x over 3x plus 8. All right. Okay, so as I said, luckily, I advise y'all not to write the first method because most don't like it. So let's do this again because there's method 2. Let's look at method 2. This is normally the way that most students like it more than method 1. If you don't have room below it, you do have room right above that problem. First thing we're going to look for is the least common denominator between every single fraction in the top and bottom. So we have 3 terms. The denominator in the first, or in the top fraction, is x plus 4. Let's look at the 2 bottom denominators. One of them is x plus 4 and the other is x. Now, luckily for us, all 3 of the denominators in the top and bottom of the fraction, so the bottoms in the top, bottoms in the bottom, are all simplified as they can get. X plus 4 is as simplified as it gets. We can't do anything to it in both spots. X, simplified as it gets. So we want to see what the least common denominator across all 3 of these are. So we can start with x. It only shows up in one place, so we need it one time. So we'll have x. Now x plus 4 does show up in 2 different denominators. But how many times does it show up in each of those denominators? Once. So how many times do we need it? Once. So the least common denominator of this entire fraction is x times x plus 4. Okay? What we're going to do, take this entire fraction, and we're going to multiply the top and bottom of it by x times x plus 4. So we're going to multiply the top of this fraction by our x times x plus 4. Now, since this is being multiplied by a fraction, this entire thing is going to multiply with the 5. So we're going to have 5 times x plus 4 all over x plus 4 on top, because it's the only term. Since we're multiplying a number times our fraction, it's going to multiply with the top. Questions on how we did that first multiplication? We're going to do a similar thing with the bottom. The x times x plus 4 is going to multiply with our 1 and with our 2. Well, our x times 1 is just going to be x times x plus 4 all over x plus 4. Plus, we're going to multiply the x times our 2, which will give us 2x times x plus 4 all over x. Questions on this so far? Questions on anything we've done so far? And at this point, you're saying this doesn't look any nicer than what we did before, yes? Okay, let's look at the top. Top fraction. Is there anything in common on top and bottom? So those are gone. Let's look at the bottom fractions. Well, here the x plus 4 and x plus 4 are in common. Here, the x and x. So let's see what's left. On top we have, so 5x. On bottom we have x plus 2 times x plus 4. Well, let's multiply that 2 out. 2 times x is 2x. 2 times 4 is 8. 2x plus x. Anything in common with 3x and 8? This, our least common denominator. So we're looking at the three denominators and seeing what's going to make them be the same. Because like what we did with addition, subtraction the last few days, trying to get the bottoms to be the same, that's what we're looking for. Because this least common denominator, when we multiply it through, is going to reduce the fraction on top and bottom. Which, as we saw here, the fraction on top here disappeared. This fraction disappeared. This fraction, they all go away, so we just have one on top and bottom. And that's the nice thing with the second method, is we get rid of our fractions on top and bottom, leaving us with our singular fraction. It is a lot less steps. And we get to the same answer. Six over x minus 2, all over 1 over x minus 2 plus 3 over x. Least common denominator, least common multiple, yes. X minus 2 is going to be contained in it. Because x minus 2 does show up once, at least once, in the bottoms of the fractions in this fraction. How many times does it show up? Yes. In each of the denominators. The x minus 2 factor, how many times does it show up in each of those denominators? Once. It does show up in two different places, but it only shows up once in any of the denominators. Because even though it does show up twice, we only need it once, because it only shows up once. Now, if we had, say, x minus 2 squared, it now shows up twice in one of them, so we would need it twice. But here, it doesn't. So that takes care of 2. There's one other factor we need. Mm-hmm. Yes. Mm-hmm. Yes, since it only shows up one time in the one spot it showed up, we only need it once. With our 3 over x, so we need it at least once. Now we multiply this here. The top fraction. We're going to multiply our x times x minus 2. We're going to multiply it through the tops. So it'd be 6 times x, which is, well, 6x times our x minus 2 over x minus 2. In the bottom two fractions. Mm-hmm. We good to scroll down? Yeah, so x1 times our x times x minus 2, well, that's just going to be x times x minus 2 over x minus 2. Now we're going to do, yes, this is going to be 3x times 2 over x. X minus 2 and x minus 2 will cancel. X minus 2 and x minus 2 will cancel. Here, the x over x will cancel, leaving us with 6x on top and x plus 3 times x minus 2. Now, we can't say it's done because there is a possibility we do have like terms on bottom. When we distribute that positive 3, 3 times x is 3x. 3 times negative 2 is negative 6. X plus 3x is 4x minus 6. 6x is on top, one term, simplified as it gets. 4x minus 6. Anything in common with 4x and 6? 2. Which means we can factor the 2 out. telling us that we have 2 times 2x minus 3. Get them underneath. Now, before the 6x over 4x minus 6, I can't reduce anything because the 4x minus 6 are only 2 terms down there are being subtracted. They're stuck together with addition and subtraction. So, unfortunately, we can't split the, so the question is, can we split the 4x minus 6 up into 2 fractions? Yes?
Why can't we keep it as 6 over 4x minus 6? Why is it that?
We classify, okay, yes. We classify something as simplified if there's no common factors on top and bottom. There's nothing that they share. So to make sure that there's nothing that they share, well, 4x and 6 do have a common factor of 2. So we can factor it out. Now, since the 2 and our 2x minus 3 are multiplied, we can now reduce that 2 on the outside with the 6 on top. Because when we have multiplied factors, we can simplify. And 6 over 2, we'll leave the numerator as 3x and the denominator as 2x minus 3. There's nothing else in common on bottom that we can pull out to be able to reduce with the top term. So this is considered simplified because there's nothing we can do, nothing we can factor out, nothing we can change. Because when we do this simplifying, really what we're doing, and the reason we can do this is I can say that this is 6 on top times x, because I can split those apart with multiplication. We can put them back together. We're used to doing that. I can do 2 and the 2x minus 3 here. Our 6 over 2 becomes 3 over 1. And we can put it back together. Which unfortunately we can't do with addition subtraction. It works a whole lot different. Does that make sense? Kind of. But this is our final answer. Nothing in common on top and bottom, nothing else we can do. It doesn't mean that there's always going to be a common factor on top and bottom. It just works out that this one here did. The last one didn't. But we factored just to make sure that it does. Are you ready for the next one? Least common denominator. So one of our denominators is 6, 3, 5, and 10. We have 4 numbers that we're looking at for the least common denominator. Well, let's look at them in pairs. What's the first number I can turn 6 and 3 into?
6.
Because, well, 6, 3 times 2 is 6. So the first number I can make both 3 and 6 into going up is 6. And 5 and 10 is 10. So really, all we're looking at is what is the least common denominator? What is the first number we can turn both 6 and 10 into? It would be 30. Because if we look at the multiples of 6, 12, 18, 24, 30, well, 10, 20, 30. It'd be tempting to say 60, because 6 times 10, but 30 is the first one. Which means our least common denominator for this here is 30. So what we'll do with this here is multiply the top of the fraction and the bottom of this fraction by 30. First number that we can turn 6, 3, 5, and 10 into. Now if we look at the top, the 30 is going to be multiplied by our x with our x over 6, which would be 30x over 6 minus. We'll do the 30 times the numerator of this fraction, which would be 30x over 3. We're going to look at the bottoms. 30 times our x over 5 is going to be 30x over 5 minus 30 times 7 is 210. Well, what's 3 times 7? 21. So 30 times 7 is 210. Questions on how we got this far? Now we need to simplify. So our first one here, 30 over 6. 30 divided by 6 is 5, and we still have our x. 30x divided by 3. 30 divided by 3 is 10. 30x divided by 5, 6x. 210 divided by 10, 21. Now let's look at the numerator first. Questions? 5x minus 10x. Negative 5x. Can we combine 6x and negative 21? 6x minus 21 is not like terms. Is there a common factor between 6x and 21? 3. So we can factor the 3 out. If I factor the 3 out of 6x, we're left with x minus 7. Numerator is factored, negative 5x. That's as far as we can go, I guess. 5 and 3, will they reduce? That's it. But again, we do that factorization, simplify as far as we can to make sure there's nothing in common on top and bottom. Now at this point here, there's no reason to multiply the 3 back through or do any products back out. This is as simplified as it gets. Yeah, you would just take it back to 6x minus 21. Questions on any of this here? So for the next one, the least common denominator would just be x. And if we multiply through the top and bottom by x, let's focus in. Our 2 over x times x is going to be 2x over x minus. Now, even though it doesn't have a denominator, it's just going to multiply with the 4 and give us 4x. For the denominator, we're going to do the same. We have 2x over x plus our 3 times x is going to be 3x. Now, the 2x over x here, the x's will cancel here. The 2x over the x over x is going to simplify to give us 2 minus, I'm ahead of myself, 4x over 2 plus 3x. 3x and 2 on bottom, is there a common factor between the two? No. So I'm going to rewrite it as 3x plus 2, getting the variables in front. Greatest common factor on top between 2 and negative 4x. 2. We can factor the 2 out, leaving us with negative 2x plus 1. Nothing in common, so that's as far as it goes. Now the negative 2x, some will say we need to factor the negative out. But if we look at the bottom, the only reason I would factor it out is if the bottom had 2x minus 1. If both signs are opposite, then factoring the negative out would line them up, and we can factor them out. But here, no, doesn't change anything. Questions on this here? Questions on anything we've done so far? Because really, this is it. I mean, we can get more factors, get more things, which isn't adding anything. Now, yeah. Now,
we learned this? The first version that you weren't supposed to write down? Yeah, we learned that. Yeah, I wrote that. I missed the part where he said you don't have to.
Yeah.
He said it after he wrote it.
I wrote it, but I made room for the second version. I did the second version.
All right, guys. I want to look at this one more time. Now,
We wrote twice.
this one here, the one we just did. Now, we said the least common denominator was just x. I'm going to do x squared. So this is over the least common denominator. It'll still work, because if we multiply the top, instead of having 2x, we're now going to have 2x squared over x minus 4x squared. On bottom, we have 2x squared over x plus 3x squared. One of these x's will cancel out on top and bottom, giving us 2x minus 4x squared over 2x plus 3x squared. Now, when we did this with just x, the denominator didn't have anything in common. Now it has a common factor of x, which we can factor out, leaving us with 3x plus 2. On top, now we have a common factor of 2x, leaving us with negative 2x plus 1. Now what do we have in common on top and bottom? A factor of x, which can be removed so here, adding that extra factor of x came back out in the end, yes? But it also, if you notice the degree of this here, instead of it being 1x or x to the first, it's now x squared. So each time we add, especially these variable expressions, just x is nice. But if we add an extra x plus 2x minus 2, these terms, it's going to make it bigger. But that factor that we add in over what we need is going to have to come out at the end. That's why we do the least common denominator, to make sure we don't go over. Huh? That wasn't an example. It was, I was just explaining.
Doing something else with this question.
To explain why we don't want to use more than what's necessary. You have 4 problems.
That's too many. Why would you do that?
Yeah.
8x. I can't make you make this. 39, 40, 42, 44.
Yeah, one of my calc classes, they gave us the assignment, which was problem, I think it was like 6 and 8. Like, awesome, 2 questions were good. We pull it up. Question number 6 had parts A through L, and question 8 had parts A through M.
I remember one time in elementary, our teacher was like, give us an assignment, and we just all did the assignment.